Hi, AppSec engineers, and welcome to our stream for today. I'm very happy to be doing this. It's been a while since I did one of these. It's been most of the team that have been doing these streams. Today, I'm really happy to be doing this because it's a conversation that I'm going to have today, which is something that I really want to have and I'm really interested in having. So I think I'm really looking forward to this particular session. Just a few updates on the AppSec Engineer front. We have released a whole bunch of courses. In fact, our course release has gone on overdrive. And in fact, we're releasing a new course on nuclei. So, all those nuclei fans who want to do dash testing with nuclei, we're going to be releasing that next week. And next week, we have a huge, big announcement coming up on AppSec Engineer. We're going to be launching something called challenges. What is challenges? You're going to learn next week. It's going to be something that's going to be really off the hook in terms of your learning, in terms of application security or cloud security. You're going to get that whole perspective coming up in terms of challenges. It's going to be a pretty big feature that we're going to be launching pretty soon. So that's also happening next week. Aside from that, if you want to learn, of course, you know where to go. If you want to learn all of these things with hands-on labs, with a lot of this good stuff in terms of content, with playgrounds, we're launching a whole bunch of hands-on stuff around all of these new classes as well. We've already launched them, and we're launching more of these as we go along. So you'll see a lot of developments on AppSec Engineer as we're going along, and that is something that you can look forward to going into this as well. Now, today, my guest today, I'm going to be doing a guest show today where I'm going to be talking to someone who's been working in the application security space for a while now. He's actually been there, done it all. He's actually been a builder in the application security space. Recently, he and his co-founder have created this company called Levo, and in fact, I spoke to them probably a year and a half ago. It's a very interesting company, and their tech was what interested me the most. And I think he can articulate it much better than I can. So I'm going to add him to the stream. I would like to welcome Harish to the stream. Hi, Harish.
Hi, Abhay. Thanks for inviting me. Really looking forward to this.
Awesome. Great, Harish. Like I said, one of the things that when you guys started talking and when we started interacting, this was what, I think 18 months back or probably even a little bit more. I'm not sure. I think when COVID was at its peak, I guess we started interacting and we met, of course, a couple of times. I was really interested in the approach that you are taking for the product, especially around the agent and stuff like that. Of course, you're going to talk about this. We're also going to do a demo and things like that. But I really was interested in the tech, and I really like the background that you came from and the way you articulated that problem. So, with that in mind, just tell us how you got into AppSec, because you are a builder, right? You've largely, I think, built stuff. So, why AppSec? How did you get into security and AppSec?
Yeah, great question. So, my career dates back to almost like 20 plus years, where I started out with Blue Code Systems. This was the early 90s where the Netscape Navigator had just come out, and the internet was such a major, crazy thing that everyone was jumping onto. And Blue Code was a system that allowed you to control, web access to different applications. So
Yeah.
a lot of
Yeah.
enterprises were about, hey, how do I control access to my, internal systems and external systems and things like that. So Blue Code became a household name enterprise, and that's where I kind of cut my teeth. Blue Code is always at the intersection of what you call infrastructure and applications.
Right.
So there's like, and from a security perspective, there's like people deep down in the networking parts, and there's people who basically span both the applications and infrastructure. So entire career has always been at the intersection of applications and infrastructure. And more recently, the last 10 plus years, what I've noticed is more and more applications are cloud based, and microservices type of stuff, and largely the infrastructure is being handled by cloud providers. So that AppSec is where the
The game is going.
exactly, yeah, yeah.
Right. So, in terms of AppSec, I mean, I know where you come from. I think APIs is your area of choice, but Why do you think this is such a big problem, or why do you think this is a problem that you wanted to spend time on and create a company? Because I mean, if you want to create a company, your motivation must be pretty hardcore to do that. So what is it about APIs security or APIs that really attractive? Because again, let's also kind of put into perspective that literally every other company today claims to be an API security company, right? You can't if you are in Black Hat or in RSA or any of these places, you will see that every second booth they are talking about APIs. So what is it about APIs that attracted you, and what is it that you felt that people were not doing that you wanted to do? Let me put it that way.
Yeah, great questions. So the very first thing I think in terms of market transitions, people are moving from on-prem data centers to cloud, and when you do that, the whole notion of the perimeter disappears, and the whole notion of infrastructure security becomes quite outdated because the cloud provider is doing a lot of this stuff. And what's exposed in terms of the attack surface is your application layer and essentially your API layer. And so today's modern attack surface is essentially, access to APIs, and APIs are nothing but conduit to data. Ultimately, people who want to go after things in an enterprise system is about going after that data, which is the goal, right? And getting access to the data is via APIs, and so that's why whether it's being external APIs or internal APIs, today you had mentioned about lateral movement and things like that. Ultimately,
Yeah.
API is the way to even do lateral movement these days. So
Yes.
so essentially, guarding the APIs and securing the APIs is becoming more and more important. And your second question is like, hey, that was the main motivation, but there's a lot of companies doing the space. But where we saw the gap was to do it in a way that empowers modern development teams to sort of embed API security into their whole development process rather than think of this as an afterthought, and also do this in a very frictionless manner compared to other techniques. We actually came from an API security company that was doing more of a web application firewall type of approach. We learned some important lessons there, and then said, "Hey, there's a different way, a much easier, more elegant way to solve this problem." That's why we
Right.
started the company.
Right. Awesome. Yeah, it makes sense. Uh, so today is API observability. We're talking today about frictionless API observability. So, what? Uh, First of all, what is API observability? I mean, just so that everybody's on the same page, because observability is this jargonized term that's thrown around all over the place, right? So, a lot of people confuse logging for observability. A lot of people conflate rudimentary monitoring for observability. What is API observability? What is your take on it, and why is it important from a security perspective? Because observability can be used for a lot of different things, but why is API observability important for security,
Yeah,
and what is
yeah. I mean, fantastic observations and question. Observability has been a the umbrella term, but in the scope of APIs, because like APIs is the modern attack vector and access to all kinds of digital information.
it? Mhm.
There are four fundamental questions that enterprises have to answer, and most enterprises are what we call as like brownfield environments,
Right,
where there's been lots and lots of APIs that have been developed over the course of time, but
right,
very poor what do you call visibility of assets and documentation exists. That's the nature of the game today, and there are four fundamental questions like, hey, what APIs do I have? What is the underlying schema for those APIs? What kind of sensitive information is being exchanged by these APIs, and who is accessing these APIs? When we say who, it's like what users under what roles or scopes are accessing these APIs. So if you don't answer those fundamental questions, or you're not able to answer those fundamental questions, then you can't really do any sort of attack surface management, because you can't secure what you cannot see.
correct.
So essentially, that's
Absolutely.
like a what do you call a baseline foundational problem that needs to be solved.
Okay. So if you were to break it down like I was five, it would probably be first you need to know what the API is, which is of course what are the endpoints. You need to know who can access the API. You need to know what they can access, and of course, what are the attacks possibilities, the attack surfaces across all these different elements. So that is basically what I understand from the definition of API observability. So one of the things that really attracted me to your approach to solving this was the fact that you are not using typical dast, although one can construe it as typical dast. What you said was essentially we're using this agent, kind of not an agent. I would probably call it a probe kind of a system, which is built on eBPF, and eBPF, as we've all a lot of us have seen, has been pretty effective with a lot of different use cases around security, especially in terms of network, in terms of so many different cases, especially in terms of being able to identify potential syscall, call different types of syscalls, to be able to prevent it, to be able to proxy it, to be able to observe it. There are so many different use cases that people are applying eBPF to. So that was really something that I enjoyed in terms of understanding how you are doing it. So I think you should take us through your take on the whole situation. Of course, give us a little bit of the juicy tech bits in terms of what it is that you're doing, and why you, of course, what is the actual reason for you approaching it this way, because the eBPF is great, but again, there are so many different ways in which you can apply it.
Yeah.
So I think it would be great if you could take us through your thoughts, and of course a demo on something like this.
Yeah, absolutely. I think the what I'm going to do is I'm going to sort of like spend a little bit of time at the high level talking about the threats in terms of the API landscape, making
Great.
it important for API observability. Like you already asked the question, why API observability? I'm just going to sort of reinforce that, and then
Mhm.
talk about our architecture, into why we're doing things differently, then get into the demo aspects of it. So, uh,
Yeah, absolutely.
share my slides here. Is the screen visible, Abhay?
Yes,
Okay,
we're
great.
good. Yeah.
So what we're seeing today is a massive shift from monolithic architectures to a highly distributed microservices architecture. And this in turn is leading to what we call as API proliferation. That's just the API growth compared to just a few years ago is just exponential. And one of our customers talks about APIs growing like mushrooms in his environment. And this is no secret, APIs has become the number one attack surface, largely because access to the critical data is via the APIs.
Yeah.
And in terms of attack surface, let's actually look at API attack patterns that are very prominent these days. The very first attack pattern is what we call as a horizontal authorization abuse. And this picture is actually from an incident that happened at Uber several months ago. Again, Uber is in the news a lot, and we're not trying to, jump into that bandwagon. This is something that happened many months ago, and it's happened in many other enterprises as well.
Yeah, of course.
Essentially, Troy is a Uber rider and wants to look at his receipts from yesterday, and so he's also curious as to what his mobile is doing underneath the covers, and so he puts a proxy like burp to understand what's going on beneath the mobile, and he sees that the mobile makes requests to the backend using an API called get receipts with an ID. And to his surprise, Troy finds that he can just enumerate receipts by just asking for numbers like 101, 102, 103. In this specific slide, receipt number 101 is owned by Troy, but receipt number 102 and 103 are owned by Scott and Kathy. And Troy is able to actually access Kathy and Scott's receipts by just simply asking for it using a tool like curl and postman, as long as he's authenticated. And he was able to access for thousands of users. Now, in the
Mhm.
industry, people often call this insecure direct object references, or IDORs, and some people also call it broken object level authorization. But this is a
Mhm.
pretty prominent pattern with APIs, mainly because of a couple of reasons. One is, unlike a monolith where granular authorization was relatively easy to implement, now you have to implement authorization across hundreds of different services and hundreds of APIs or thousands of APIs. And often these services are owned by disparate, smaller, what we call service teams. And often these teams are geographically, separated across different time zones.
Right.
And so implementing a consistent authorization model across all these services, because from an application perspective, you only have one authorization model, but from an implementation, you have hundreds and hundreds of services where you have to implement this. And even if you get it right the very first time, preventing regressions on a daily basis, because you're pushing code almost every day, and
Yeah.
hundreds of services are pushing code, and how do
Yeah.
you prevent regressions like this from happening? It's a pretty big challenge. So
Right.
that's why we see this kind of pattern exploding in the context of microservices. We see other patterns as well. There's another pattern called vertical authorization abuse. And in security parlance, some people call this just privilege escalation, where you have roles or OAuth scopes for APIs. And what is a role or a scope? It's just nothing but, hey, what kind of API can you access, and what information that you can access from that API? That's what a role or scope controls. And when the bug bounty program people look at this type of stuff, they get really excited, because oftentimes they're able to do a privilege escalation where they take a role with lesser privileges and have it access more information than necessary. Again, why is this a pattern that is very prominent with APIs and microservices? Largely because of those three reasons, or two reasons I talked about earlier. And I think, Abhay, you've also mentioned in your AppSec things many times that getting authorization hard,
Yeah.
right.
No,
It's
it's hard. It's probably, I would say, one of the most complicated things, simply because, one, it's, yeah, like you said, yeah, it's not, it's one of those design things, right? Whenever there is a design or architectural consideration, that's when, and if that has not been considered, which it many times it's not, it tends to be a cascading effect that has things like this. So it's pretty complicated. A lot of people assume that you can just use UUIDs to fix the problem, to say, hey, just use UUIDs, you can obscure the problem. Yes, you can obscure the problem. That's the
right.
important. You can't really fix it without really having an authorization in place. And with API is, I think, the other kind of underrated thing that people don't really talk about with APIs, and why authorization is hard with APIs, is also because you don't really have a visual authorization component with APIs, right? With your typical browser-based applications of MVC, your MVC apps, you used to have this UI that would kind of work as an authorization flow in itself, right? You would remove certain functionality, and unless somebody really enumerated and tried to even then it wouldn't really work. But unless, so there was a lot of visual barriers from an authorization standpoint, aside from, of course, all of the stuff that you mentioned. That's absolutely correct. But I think today you have too many different objects, you have too many different ways to access those objects, and implementing authorization is hard, simply because it's a design level consideration, and most of us don't really think about it. Especially, let's say we add a new resource, suddenly there is this entire new authorization paradigm that you have to keep in mind, which becomes complicated. Yeah, absolutely.
Yeah, that's very insightful in terms of the MVC example you gave. That's absolutely bang on. Let's actually look at one more pattern that's again prominent, and sort of like fundamental principle in security is, hey, don't trust data blindly, and make sure that you do the proper data validation before you consume the data.
Right.
And it's an easy thing to say, very hard to implement. And people have talked about SQL injection for 30 plus years. That's still a possibility. But with the
Yeah.
APIs, if you look at the surface area over which you don't need to do input validation, it's actually pretty big, because if you look at most APIs are implemented over the HTTP protocol, and then you have the what's known as the request method and the request line. You have request headers that need to be validated. You need to validate the entire request schema. And when it
Right.
comes to responses, again, you can't just blindly trust the response part. There's a response code, the response headers, and the response body. And today, developers, there's a couple of issues. One is awareness of, hey, we need to pay attention to validation of data. The other aspect is, even if there is awareness, a lot of people are focused on implementing business function, and doing all this data validation is actually a very boring thing. And some of this stuff frameworks can handle, but a lot of this is very business logic specific. So we can't say, hey, just get the default frameworks that handle all this by default or secure by default type of stuff. That is there to some extent, but many of this is like very specific to how we have implemented APIs. So you can escape that validation completely, and it doesn't come for
Yeah.
free.
Yeah.
And because of that suboptimal validation, a whole bunch of issues. And then something that you had actually brought up in AppSecEngineer a while ago, something called mass assignment, that can lead to many problems, including privilege escalation. Indirectly
Yeah.
privilege
Yeah.
escalation. Um,
Absolutely.
so yeah, so that's why I think APIs being the attack vector. You talked about even lateral movement today or yesterday, where even if somebody breaks in using an external API, and then now the way they do lateral movement is via the APIs, and
Yeah.
so it's very important to get observability and answer those 4 or 5 fundamental questions we talked about earlier in the show, and
Yeah.
and that's where we have come up with a very unique solution, what we call as frictionless API observability.
Right.
So the next slide is talking about the architecture before going into the demo component. And
Yeah.
this thing on the left-hand side is a customer premises or VPC if they're running in the cloud. More and more microservices are being orchestrated using Kubernetes. So I'm showing you clusters, production, staging, pre-production clusters running Kubernetes. And
Right.
within those environments, what we do is we install a sensor that is built using eBPF or extended Berkeley packet filters. Now,
Yeah.
why is this unique and different? Because like many AppSec companies claim to provide API observability, and they do provide API observability to some extent. And how do they do that? It's largely using RASP agents. RASP agents is nothing but an agent that gets injected into your Java code at runtime or a .NET code at runtime, or they will provide what is known as sidecar proxies, which are man-in-the-middle proxies, so reverse and forward proxies, or they will provide SDKs that developers have to embed as part of their application development process. Um, and all these 3 types of techniques, what they do is they collect runtime traffic for analysis to provide that visibility or observability. But we've been in the instrumentation business for 10 plus years, and we've repeatedly seen this causes a lot of friction between security engineering developers and DevOps teams. And
Right.
reason why is security will say, hey, this gives us very important, it answers those 4 or 5 fundamental questions. So I want you to embed this agent within as part of your runtime environments or add these proxies. But invariably, when adding all these things, it either increases latency or causes some sort of stability issues. And even if the reality is, even if these things don't add latency or don't cause any stability issues, there's always people, DevOps and developers, when they're trying to debug something, it's a natural thing of isolation. Like, hey, there's a component that we didn't want that security engineering added, and I naturally will suspect that component that did that add the latency, or did that cause the crash, or did that cause the malfunction. So in a lot of enterprise environments, what happens is because of this external thing added into the developers' applications, debugging becomes complex, and that leads to finger pointing and unhealthy collaboration efforts. So that's why we've
But
taken
not
our
just that, right? Because you have, and you also, with RASP and stuff like that, you also have a host of issues in terms of the frameworks and the languages that are supported. It needs to match. It needs to be a true marriage of sorts, and there can't be any sort of incompatibility. And if you are using a stack that is marginally different, or that is using a framework that they don't support, then you're again out of luck. I guess that's also one of the issues. I'm guessing that's
Yeah, absolutely. I mean, I mean, you brought the right point here. It's framework compatibility. The other part is like today, more and more application teams or microservices are built using polyglot environments where you're running multiple languages. And then if you
exactly.
go to the RASP solution, you have to ensure that every one of these languages has RASP support. And oftentimes, RASP is very suited for languages like Java and .NET, but not doesn't work with things like Python and Go and things like
Yeah,
that. right.
it's hard to trace. I mean, if you try and trace with Python, I mean, you can, but yeah, your RAS provider really should have done a phenomenal job. But it's not always the case. The rules I mean, you have to rely on them for rules. Writing custom rules becomes a problem. So yeah, I get completely.
Absolutely. So that's why we've taken a very deliberate approach of using eBPF, and eBPF has been used in the security community for several years now, but largely in the infrastructure space where they're tracing syscalls and doing things like anomaly detection for intrusion detection systems. So
Yeah,
many solutions, including an open source system called Falco, that's
yeah,
extremely popular, is about intrusion detection using syscall behaviors, or even antivirus companies, or what do you call EDR, or companies are using eBPF to look for malicious behaviors of
and now
any.
you're seeing things that evade eBPF as well, right? So
Correct,
you have
correct.
a new strain of malware that is now starting to evade eBPF based checks. So yeah,
Correct,
absolutely.
correct. Well, one more point I missed is like, any sort of security solution has to be tamper-proof, in the sense that with AppSec, if you have to individually control every single application workload, developers or DevOps communities have the capability to say, "Hey, I'm going to shut off this solution
Yeah.
because I'm debugging something." So,
Yes.
but if you do something at the host level that's not in line with the actual application workload, you can't just shut it off because it's running at the host level. And that's
Right.
what eBPF allows us from an AppSec perspective, because it's operating at the host level. It's not in line with the application. It's completely passive. And it allows us to tap into all the API traffic in these pre-production and production environments. And
Right.
we without actually adding any latency or impacting the application workload. And
Right.
fundamentally, people will ask me, "Hey, how is this different from network packet capture that's been around for 40 years?" Right? BPF was
The
the
original, the OG.
yeah, yeah. And with network the thing is, more and more workloads today are TLS, and with network packet capture, you're not going to get any visibility into TLS. But we're going to talk about the specifics of how we implement eBPF. But eBPF gives us visibility into TLS workloads, because we can tap into before the encryption happens, and capture
Yeah.
data at the pre-encryption layers or post-decryption layers. And so we capture all this API traffic, and we provide the discovery, which is like, auto discover every single API endpoint, auto generate the schema or open API documentations for the entire APIs that we discover. And there's many more components to observability, which we'll get it during the course of the demo. But essentially, when customers look at this, they like the fact that we're able to discover APIs in a frictionless manner. But
Mm.
most people have concerns, in the sense that, hey, are you saying that you're collecting API calls and you're sending it into your cloud? Typically, solutions in the space are SaaS solutions. So
Mm-hmm.
you're sending your collected API data from your premises, your VPC, to the vendor's cloud. And when you send it to the vendor's cloud, pretty much all your API data, including sensitive PII, PSI information, will go to the vendor's cloud. And their concern is like, hey, that is a big no-no, because like, I can't send my precious data into your cloud. That extends my boundary, and then I have like privacy and compliance issues because of that, and it violates a bunch of things. That's where, again, we've taken a very, very deliberate approach of building something that will not consume your data directly. We have introduced something called a satellite that runs within the customer premises, and the satellite ensures that none of the data is actually directly ingested. And so this is what we call as a privacy preserving technology, where on the left hand side is a trace, that is API trace, that was captured by the sensor and sent to the satellite. And if you can see, it's a little small, but there's a bunch of data, including PII and PSI data, like card numbers and zip codes and things like that. And
Right.
what the satellite does is it just does data inferences. So we infer the underlying schema for that API call. What do we mean by that? We're extracting the actual data types for those key value pairs. Rather than
Right.
actually consuming the data directly, we're doing the data inferences. And what gets sent into the vendor's cloud environment is really the data inferences of the OpenAPI schema.
Right.
And top of that, the satellite is also providing another role. It is doing what is known as sensitive data detection. So we have a pre-trained machine learning model running in the satellite that's looking for PII and PSI data like credit card numbers, zip codes, and email addresses, and then annotating the OpenAPI specs with that information. So you not only get the full JSON schema, the JSON schema will also have indications saying that, hey, this field is likely a credit card number with this much confidence. So you have an idea, because like ultimately observability, a critical part is like, hey, where does sensitive data exist and which APIs are consuming or exchanging sensitive information. So that this aspect is very, very important.
Right.
Now, one key difference between how we're doing it was versus other vendors. Other vendors will also say, "Hey, we can redact sensitive information before sending it to the vendor's cloud." But the problem with redaction is like it's a best effort thing. If you exactly knew all your sensitive information, you could write regex rules to completely redact them. But the reality is, there's many types of sensitive information or sensitive formats, and not everything is standard. So it's really hard to make the claim that, hey, we will not consume sensitive information to the vendor's cloud. The only way to guarantee that is to have a promise that we will never ingest the real data into the cloud. So that's a big distinction of how we're solving the problem compared to other vendors. And this we've learned the hard way, because having been in this space for a while, we tried the previous approach in other companies, and we ran into situations with customers where we were actually leaking customer data into our clouds.
Right. Of course.
So let's actually get switched to the demo part, and I'm going to touch onto the technical aspects of how eBPF works and all that stuff during the course of the demo. But for the demo, we have this application that's highly vulnerable called Crappy, a completely ridiculous API. This is actually an open source application sponsored by the OS Foundation. It
Mm-hmm.
is a polyglot microservices written in multiple languages, all interconnected by APIs. And it has a Angular front end. It has both mobile and web. I'm going to show you the mobile version, the web version today.
Mm-hmm.
And so that's what we're going to use to demonstrate observability and a bunch of other aspects regarding eBPF. So let's actually look at where Crappy is running. I'm actually have a Kubernetes cluster running on my machine here, and Crappy has already been installed. So if I look at the pods, Crappy has many pods, and you can see that here. And
Mm-hmm.
Crappy has a web front end, which I'm going to show you in a few seconds here. So this is the application, and I've opened developer tools network tab in the bottom so that we can see the different APIs that are being used by Crappy. So when I
Mm-hmm.
log in, so Crappy is actually a car concierge social network type of stuff where you can go
Mm-hmm.
register your car, and there's a bunch of mechanics registered and a bunch of other users, so you can not only get information about cars and modifications that you can make. You can also have interact with mechanics and get services performed in your car and things like that. So it's a social network around car enthusiasts. Has a bunch of tons of APIs, ability to contact mechanics, look at your service reports,
Okay.
history of services and things like that. You can also shop for a bunch of products, and sell your products, shop for products and things like that. But the key thing I'm trying to bring out here is like it uses tons and tons of APIs. That, as you can see, that's a bunch of APIs that are being called on the bottom. There's also an API Explorer that tells you all the APIs that Crappy uses. As you can see, it's quite a number of APIs here. Now,
Right.
in a brownfield environment, you're not going to have this documentation. Think of this as an enterprise app. All this documentation doesn't exist, and that's where API observability comes in, where you have to discover these things. Somebody has to
Right.
spend the effort either manually or use a tool that auto discovers those APIs, right? And that's what we're going to
Right.
show you how we can do this all in a matter of like observing real time traffic. So what I'm going to do is I am actually going to instrument this Kubernetes cluster with the eBPF solution that we just talked about. So
Mm-hmm.
Crappy is running in its own namespace. And what I'm going to do is Levo has a eBPF sensor and satellite. So I'm going to use a single Helm command here to
Mm-hmm.
install those components. So when
Mm-hmm.
I hit this Helm command, that is actually going through the process of installing those instrumentation components, sensor and satellite. Now, if I look at the pods in this environment, in this namespace called Levo.ai, we see that we have the satellite. The satellite has many components and the sensor here. So this is the sensor that's running. And so what we're going to do is we're going to start load on Crappy, so we can generate, using Locust,
Mm-hmm.
simulate how humans actually use Crappy. The web front ends.
So it's like an end-to-end test,
Correct,
but
correct,
we're using a load testing framework for it.
correct, correct. And while we're going to generate load, the sensor is going to start collecting a bunch of traces and sending it to the satellite, and then from the satellite, it'll go to the Levo SaaS to provide the API observability. But before doing the load gen, I just want to start looking at the sensor collecting traces. So we have an idea of how many traces are being collected. So I'm just going to copy the pod here and start a tail on it for the logs. So I'm just tailing this, and now I'm going to go start the crappy load gen using something called Locust, which is a
Mm-hmm.
Python tool that is very popular. So when I start this, as you can see, it is starting to hit a bunch of APIs. And switching to this tab here, we'll see that the sensor is already starting to capture a bunch of traces. And you can see spans is a terminology coming from the OTel community. A span is nothing but an API trace. So all these traces are being captured. And now what's going to happen is I'm going to actually show you the Levo SaaS console. So we have, if you log into the Levo, ultimately all the traces are going to show up in the API observability part's going to show up in Levo. Now we have something called API catalog where everything is going to show up. This whole process is going to take about 4 or 5 minutes because the real-time traffic has to be ingested, the schema has to be inferred, and ultimately everything will show up in this screen here. But while we're waiting for the 4 minutes, we can now spend the time on talking about the underlying way eBPF actually works. So what we call
Mm-hmm.
as an eBPF primer. So eBPF, how does it work? So you have user space and then the Linux kernel.
Mm-hmm.
And inside the Linux kernel, so you have application workloads at the user space. And application workloads typically use what's known as Linux system calls, especially TCP calls like send, receive from, send to actually communicate for those HTTP calls. API calls go over HTTP, and all HTTP traffic goes over TCP. And so
Mm-hmm.
essentially, all API traffic is going through these fundamental system calls like send, send to, receive from, and things like that.
Mm-hmm.
And there's also user space functions. So whenever data has been encrypted or decrypted, functions like SSL read and SSL write using the SSL libraries
Mm-hmm.
are performed by the application workloads. So how do we actually capture data, pre encryption and post decryption, and also clear text traffic, right? I mean, that's the
Yeah.
question we're trying to answer. And how does eBPF help us do that? So inside the Linux kernel, we have what is a virtual machine, a eBPF virtual machine that has a set of instructions that allows us to embed probes into appropriate system calls. So you can have your user space, what do you call, controller, or in our case, we call it the sensor, where we send in instructions to the virtual machine. That is the eBPF code that tells the virtual machine to put what is known as K probes and U probes. And I'll explain what probes mean here. Like pretty much every developer is very familiar with breakpoints in using a debugger. And how do breakpoints work? Breakpoints use something called a technology called ptrace,
Mhm.
where on a line of code or at a symbol, you can instruct the machine to go put a halt instruction so that it waits there for you to inspect a bunch of things. So eBPF is very similar. It's much more efficient than it's even though philosophy wise it's the same, from an efficiency, the orders of magnitude much better. So
Mhm.
it uses something like similar to debug points in a debugger. It uses K probes, the kernel probes, to instrument system calls at the kernel level, and it uses user probes to instrument user space level functions. So you can actually put a kernel probe at any system call as long as you have a symbol available for the system call. And similarly, you can put a user space probe at any sort of user space function as long as the symbol is available. So what we do is to tap into clear text traffic that is transporting API calls. We instrument all the socket related or TCP related system calls, which is the send, receive, send from, send to, or receive from. And then there's also vector, write v and read v type of system calls. And then on the user space side, because we want to get pre-encryption traffic and post-decryption traffic, we go put probes on the SSL read and SSL write, and that covers almost 90% of SSL traffic. There are some exceptions, like certain things like Go libraries use something known as boring SSL, and boring SSL has different functions that we have to instrument. Similarly, Java has its own SSL stack. It doesn't rely
Yeah.
on the
Oh.
underlying Linux's SSL stack. So we have to put a
JavaX.ssl, I think.
correct. So we have
Mm.
to put a U probe on those specific symbols. But
Mhm.
essentially, what are these probes doing? It allows you to inspect what is happening at that function level and copy data. And the next slide is actually going to explain how that works. So actually I missed one point here. When the probes hit, what happens is it allows you to copy data from the kernel or from the user space into your own sensor, using a capability that eBPF provides called maps. Maps are a way, it's kind of a memory mapped, talking about memory map data transfers. It allows you to transfer data from either the kernel or from a different use space function directly into your memory. So essentially, it's copying data from the system calls, using direct memory access into your memory space. So that's how you're able to peek in and snoop the traffic. But let's
Mhm.
actually look at the anatomy of an eBPF trace. And for this slide, on the left-hand side, we have a client, something like curl or postman, that's going to make a request to an API server. And on the right-hand side is an API server that exposes an API, and then, it's a Python API server. And the way the client's going to make the request is it's going to make a GET request, and the API has a URL demo hello world. And let's observe what happens within the server here. So when this call happen, when the client actually makes the call to the server, what happens is the server has a system call that gets invoked called receive from. And that receive from call is where the server is actually reading the entire API data for processing. And because we have K probes installed in all these critical system calls, the K probe will trigger, and the probe has its own function, and within the function we're allowed to copy the data into a map. So you have what's known as an entry probe and an exit probe. And the reason we have two probes is you need to know when a system call happens, when the start of the system call and the end of the system call,
And
because you need to know when does data start and when does data end. And so
right.
you instrument both the entry point of the system call and the exit of the system call. And between the entry and the exit, you copy all the data into the BPF map. And
Mhm.
this BPF map, like I mentioned in the previous slide, is what's actually copying the real data from the server into the sensor.
Right. It's
And
kind
then
of like an event, a hook that you add based on an event being triggered on the
Absolutely, absolutely,
current.
yeah. I mean, most modern frameworks have promises and things that, right?
Yeah.
Event hooks. And this is sort of like I mean, I won't call it a promise, but it's the same thing like you mentioned. It's like it's constructed like an event hook.
Yeah.
Um, and so on the return side, so once the server processes the request, it has to munch the request and then send a response back. And when the response is sent out, typically that response is actually sent over the wire using another system call. In this case, it's using the send to system call. And a similar thing happens because we put K probes at the send to system call. We have two, we both instrument the entry point for the send to and the exit of the send to. And between these two things, all data that is being sent is copied into the BPF map and then transferred into the sensor. And then
Yeah.
finally, the response gets out. The HTTP 200 OK gets out to the client. But the moral of the story is like now we have the full request, including the payload, and the full response, including the payload, copied as a single API trace into the satellite, and then that being sent finally into the cloud.
Right.
So yeah, that's how the BPF system works. Let's actually now switch gears, go back into our console, and look at what we have found. Now you can see that we have actually auto
Covered those. Yeah.
these services for Crappy. Crappy had 4 services. It has a web service. It has an identity service, workshop, and community. So we've discovered all these things. And you can see that we're also finding PII or sensitive information in these services. Let's actually open one of these. Let's actually open Crappy Web because that's the gateway for all the services. And you can see that it has a number of APIs that were discovered, all from just observing the real-time traffic. And if
Right.
I open one of these things, we tell you what kind of authentication is being used. In this case, we're using bearer tokens or JWT tokens. We're also telling you that we're finding PII in the response. In this case, the PII was an email address that is being exchanged with this API. So you kind of get a high-level overview of all the APIs. But the more important part is like, hey, how do I get the underlying schema for those APIs? And that's where we have the schema tab exists. And if we open the schema tab, we're just reusing a Swagger component here in this UI, and that's why you see a very Swagger-like view. This is essentially if a developer had written API documentation using something like Postman or Spotlight, it would look like this. And we've completely done this by just observing traffic. And if I open any of these things, you're going to see the full underlying schema being discovered.
Mhm.
And then we've also normalized in the sense that we've found all the common objects, and we've normalized the schema at the very bottom, just like how Spotlight would do it. So
So
all
in gRPC, would you be so if this was implemented for gRPC, would you be creating protobufs out of protobuf specs out of this?
Yes, absolutely. So this specific application does not have any gRPC calls. That's why you're not able to see this. But
Mhm.
what we will do is we will actually show you the protobuf schema for
Mhm.
gRPC. If
Mhm.
you don't give us access to what is known as the dot proto files,
Mhm.
the schema will just say number 1, number 2, number 3 for the key names. You will find the actual the string integer type of stuff we would have decoded that. All the
Mhm.
PII we would have decoded. But without the access to the protofiles, the key names, we don't know what it is, right? Because we on the wire, these are being transmitted as number 1, number 2, number 3, number 4.
Right. Right.
But the moment you give us protofiles, what will happen is like we will immediately bring in all the information and show you the actual real key names.
And what about GraphQL? Is that also automatically inferred, or is there some complexity there outside of this?
Yeah, great question. So GraphQL, oftentimes what happens is like observability with GraphQL is not that much of a concern, largely
Mhm.
because you have this introspection in many of
Yeah.
your GraphQL gateways. And with introspection, the schema is fully available. But in some
Mhm.
cases, people shut off the schema, so we can auto discover GraphQL. We That's a roadmap item in our product today. We don't have it as yet. We actually, because GraphQL goes over HTTP, we actually get the data. We're just not rendering it as yet, but it's a roadmap item where we can actually show this underlying schema. But it's
Right.
less of a concern in enterprises because of the introspection capabilities.
And also because GraphQL kind of sucks nowadays. So I guess that also.
Uh,
Anyway, I'm sure I'm going to start a flame war because of that. But anyway, please go ahead.
So yeah, so that's kind of like the observability part. But beyond observability, we have more capabilities. Let's do a time check. I mean, how are we doing on time, Abhay? Do we have a
I
few more
think we
minutes?
have another 5 minutes. Yeah, I think we have 5 minutes.
So we could basically very briefly touch on, okay, what is beyond observability? Because observability sort of answers like 4 or 5 fundamental questions, but
Right.
how do you actually be proactive in beating up your APIs and embedding API security as part of your development pipeline and ensuring the APIs that you actually promote to production are pretty robust? How do you do that? And that's where we have the second part of our solution, which is the what do you call the testing part or security testing
Mhm.
part. And this side kind of gives you a high level view of how that works. On the right hand side, you have the customer premises where you have the dev staging and production pipelines. And today, developers are, whenever they do a PR, they typically use quality gates to run a bunch of functional tests for APIs using things like Postman and Newman. And essentially, what Newman is doing is executing a Postman collection and checking the functional aspects of an API. And when things pass, a PR gets promoted into the dev environment, and then a bunch of other quality gates run. Eventually, code gets promoted all the way into production through via all these quality gates. And when we talk to customers, they say, "Hey, what is missing in these quality gates is something that does the security validation as well." I mean, we do a lot of functional validation, but we don't do any sort of security validation for those APIs. And essentially, what validation we showed you, we talked about API patterns of abuse earlier. It's this authorization abuse, the vertical, horizontal, the data validation issues, and none of that is being done today. And so what we wanted to do was we wanted to make it very easy for development teams to take a postman like approach to security. And we have designed a product very similar to Postman Collections.
Mhm.
And we also have Collections has a runner called Newman, and we also provide a runner very similar to Newman. So on the left-hand side of the slide, because we've auto-discovered your API endpoints and its underlying schema and its underlying access patterns in terms of which roles are accessing these APIs. What we do is we generate an internal threat model, and what I show you as Graph IQ is actually the threat model. And
Mhm.
just like a human would sit down and say, "Hey, this API has all these things. What could be the possible attacks?" We've built
Yeah.
a threat modeler that it's an internal. We haven't exposed it. The customers are asking us to expose that. We are working on it, but essentially that threat model is actually spitting out a bunch of security tests for you. So essentially,
Mhm.
the outcome of the threat model is tailored security test plans, and these test plans are modeled very similar to Postman collections. And so
Right.
essentially, what a developer needs to do is take one of these security test plans and embed our CLI in one of the quality gates, and the CLI is just going to pull one of the test plans and execute it in the quality gates. Just like they're running Postman collections, they would run our test plans. Our test plans is going to abuse that API uh, 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 to various different attack patterns and spit out results in both the build directly in the build, like just like they do functional tests, and also send pipe the results into our SaaS. So
Right.
that's how at a high level the testing works. And I'll very briefly touch going back to our SaaS console. We have test plans. I'm going to show you an auto generated test plan here. See, I'm having a transient network issue here. Okay, got it here. So yeah, this is an auto-generated test plan from one of our auto-discovered catalogs. And test plans are very structured, very similar to Postman collections. We have
Mhm.
this of test suites. So
Mhm.
every single endpoint is a test suite on its own, and test suites have test cases underneath that. So
Mhm.
if you look at this API endpoint that has vehicle ID, and if I open
Mhm.
it, it has like 11 test cases. So opening this has a bunch of test cases, and because we talked about horizontal authorization abuse earlier, let me just open that one here. This is a test case we talked about earlier on in this in the presentation, where we talked about Troy and Scott and horizontal authorization abuse. So we've generated a test case for that, and this is the auto generated code. And what is the auto-generated code doing? It's sort of mimicking a human testing the stuff. And how do humans test a scenario like this? For
Mm-hmm.
humans to test a scenario like this, they need two users. One is they need Scott's credentials and Troy's credentials, and also a resource owned by Scott, in this case, a number like 103. And
Mm-hmm.
first, the human would log in as Scott and access the resource 103 and save it away. And then
Mm-hmm.
they would log in as Troy, access the same resource 103, and then do a bit by bit comparison to see if the resource matches. And if the
Mm-hmm.
resource matches, and that is essentially a vulnerability, right? And so instead of a human having to do this across many APIs, and that's what pen testers do today, we automate
Mm-hmm.
the whole process for developers. And so you're not only helping developers find issues the very first time. The more important part is like preventing regressions, because like regressions are very easy these days, because like you're pushing code so many times a day, and without these
Yeah.
automated tests, it's really hard to prevent regressions.
Right. And how do you handle so yeah, in this case it was a bearer token, but how do you handle more different types of authentication schemes? So because you are really looking at capturing traffic and using the captured traffic. So
Mhm.
what is the approach that you typically take?
Yeah, so we support many authentication schemes. JWT bearer tokens are a common thing with APIs, but many
Yes.
customers still use cookies. Some
Mm-hmm.
people use basic authentication. Some people
Mm-hmm.
use Kerberos. So
Mm-hmm.
essentially, we have support for all those types of authentication schemes. And the way we have done authentication is, well, because we're a cloud-based solution, we don't want customers to come and give us credentials. So similar to Postman collections, where you have this whole idea of an environment, and the environment file sits outside of the collection. So that way you have
Mm-hmm.
secrets, you have authentication schemes all stored on your environment, and how the test plan basically just references that file. And this
Mm-hmm.
is a format of a file where we show you that, hey, in this case, the way the authentication works is it's using a login API with a bearer token. But we similarly we support cookies, basic auth, Kerberos, or any custom authentication scheme you have. All those things can be easily implemented, because like it's just a matter of provisioning it using a JSON file.
Right. Right. Yeah. In any case, you're not handling that. So okay, well,
Yeah,
got it.
we're not keeping the secrets on our side. This whole environment file
Yeah.
exists in the customer
Yeah. Yeah.
environment,
Yeah.
and it's just given at the time of execution. So when I run this test plan, the way to run this test plan is, this is the command to run the test plan. And Levo
Mm-hmm.
test is nothing but our CLI runner, which is similar to Newman. It takes a test plan, it takes a target API, and then it takes an environment file. So this environment file actually sits in the customer environment that has all the secrets, and is in JSON format that specifies the type of authentication and all the credentials.
So yeah. So just no, I have a question around the authorization testing, right?
Mhm.
So the case that you brought up, which is Scott has one account, Troy
Correct.
has another account. So you
Correct.
basically use Troy's token access and see whether you can access somebody else's. Then use Scott's token and see whether you can access somebody else. Now, obviously, these are ID tokens. They may be JWT ID tokens. They may be so. How do you handle? So, does it have to be executed immediately, or how do you handle things like refresh tokens and stuff like that? Because these
Yeah,
tokens are typically short-lived, right?
yeah, absolutely. So we're not asking for the actual authentication JW token for the for logging in as Troy and logging in as Scott. You can give us those things, but
Mhm.
here the way we've implemented is like, hey, you give us your password and your username as part of the environment file, and we will actually invoke the login API, appropriate login API for to actually
Okay.
extract the access token. So we're not, we have the flexibility to use both tokens directly,
Mhm.
or get the token using a login scheme.
Okay. Okay.
So
Okay.
here I can show you what we've done is like there are multiple users, because like I haven't named the users Troy and Scott, but essentially user one represents Troy, user two represents Scott, and
Mhm.
here there's a username and password, and there's an authenticator scheme called the crappy authenticator scheme. And if I look at the authenticator,
Mhm.
the authenticator that's been defined called crappy, what it's saying is like, hey, use a URL or API called login API, and it takes in the body an email and a password, and the key names are username key and password key. And then on the response, use a credential extractor. So we're basically defining a credential extractor, and that credential
Right.
extractor says, hey, the credential is going to be a bearer token, and the
Mhm.
exact location is going to be in the body, and the JSON path of that credential token is going to be dot token. So
Right.
that's how we give you the flexibility to say, hey, you can either use an API to extract your login credentials, or you can give us login credentials directly. Either one works.
Right. Got it. Understood. That's awesome. This is very interesting, Harish. I think yeah, I think a lot of at least I think the eBPF coverage was very useful as far as I'm concerned, and I'm sure a lot of the people who are viewing this and who are going to view this over time will appreciate that. Um, yeah, so thanks so much for spending your time and being with us today, and I hope uh, for those of you who are watching either live or who are going to be watching after the fact, I hope you enjoyed, because this is I think it was a pretty useful deep dive into a different kind of an approach as to how you can do observability for APIs. And again, observability doesn't mean only just gathering inputs on or mapping the APIs, but it also means who has access, how they have access, what kind of course, what kind of monitoring that is there. That also becomes part of observability. So I think that's a valid point that Harish brought about as well. Thank you so much, Harish. I really appreciate your time. Thanks so
Yeah.
much.
Thanks, Abhay. Thanks for this wonderful session. Really enjoyed it. Looking forward to more sessions in the future. Yeah.
Absolutely, yeah. No, this was a lot of fun. I think we should do a little bit of a deeper dive in different areas next time and see where
Yeah.
we go with this.
Excellent. Yeah.
Thanks so much.
Have a great evening. Yeah.
Bye. Thanks so much.
All right.